Hello friends, welcome to my channel DC Math. dy by dx plus py is equal to qy to the power n, where y is the independent variable, where y is the dependent variable and x is the independent variable. P and q both are functions of x only. This type of equation is called Bernoulli's equation. This type of equation is reducible to linear form by the substitution y to the power 1 minus n is equal to v. After substitution, we get this equation, which is linear in v. Therefore, the integrating factor is e to the power 1 minus n p dx, that is e to the power 1 minus n integration p dx. Using this as integrating factor, we can solve this equation. By this method, we shall try to solve this equation. Comparing the given equation with the standard form of Bernoulli's equation, we get p is equal to cos x and q is equal to sin x. From the above equation, we see that by the substitution v is equal to y to the power 1 minus n, this equation can be transformed to this form. Therefore, by the substitution, putting y to the power 1 minus n is equal to v, we get dv by dx plus 1 minus n cos x into v. Here we get dv by dx plus 1 minus n p into v. Here p is cos x. Here p is cos x. Therefore, 1 minus n into cos x into v. We are getting this thing. And here we get 1 minus n into q. Here q is equal to sin 2x. Therefore, we are getting 1 minus n into sin 2x. Ultimately, the equation becomes dv by dx plus 1 minus n into cos x v is equal to 1 minus n into sin 2x. This equation is linear in v. Therefore, integrating factor is e to the power 1 minus n cos x, e to the power 1 minus n integration cos x dx, that is e to the power 1 minus n into sin x. This is the integrating factor of this linear equation, which is linear in v. Multiplying both sides of equation 2 by this integrating factor, we ultimately get v into e to the power 1 minus n sin x is equal to integration sin 2x e to the power 1 minus n sin x 1 minus n dx. We are getting ultimately this thing. We are putting 1 minus n here and breaking sin 2x to 2 sin x cos x, and e to the power 1 minus n sin x dx. Ultimately, we are getting 2 into 1 minus n integration sin x cos x e to the power 1 minus n sin x dx. Let us put sin x is equal to z. Therefore, cos x dx is equal to dz. Putting this in this equation, we get sin x is equal to z, therefore v e to the power 1 minus n into z. We got this thing in the left hand side. After that we are getting 2 into 1 minus n integration. We are putting sin x, we are putting z in the place of sin x, therefore we are getting here z, and here we are getting e to the power 1 minus n into z, and cos x dx gives dz. Therefore in the place of cos x dx we are writing dz. After solution we are getting this thing. Ultimately we are getting this thing. By the integration of this part we are getting this portion, d by dz of z is equal to 1. After that integration of e to the power 1 minus n into z dz is equal to e to the power 1 minus n z divided by 1 minus n. After the integration e to the power 1 minus n z dz, we get e to the power 1 minus n z divided by 1 minus n. After the integration of this part, we ultimately get 1 minus n whole square into e to the power 1 minus n z. Here c is the arbitrary constant of integration, which ultimately gives, here we shall put z is equal to sin x. We are getting this thing after putting the value of z, which was z is equal to sin x. Now we shall put the value of the variable v. Putting the value of the variable v, which is y to the power 1 minus n, we get